Section 2.4, page 3. Now let's go ahead talk about derivatives of trigonometric functions. So far we've discussed the derivative for the sine and the cosine, but we haven't talked about the other trig functions, but we can now, because essentially they're all quotients of a sine or a cosine, and therefore we can use the quotient rule to find their derivatives. For example, if we're asked to find the derivative of the tangent, we're going to need to use the quotient rule. So we'll think of the tangent function as the sine over the cosine, which is a numerator who has a derivative, which is a denominator who has a derivative. So taking the derivative of, I actually wrote this should say numerator, right? Then we're going to write the cosine first, and this should just say denominator, and so then I'm going to write the denominator next, but I do have the minus correct. Now I should really say d prime, which is the negative sine of x, so I correctly wrote this, and then this should just say n, which is our sine of x, which I correctly wrote. And then remember, we take the denominator squared, which is this cosine squared. So I've got a cosine times a cosine, which is cosine squared. I cannot just cancel these, even though people want to. I have a sine times a sine, which is sine squared, and because I have a negative times a negative, I have plus 1. Hopefully you remember the cosine squared plus the sine squared is just 1. So this numerator simplified to be 1, and now I've got this denominator squared. But if you remember by definition, 1 over the cosine, I should say, of x is the secant of x. So that means 1 over the cosine squared is the secant squared. Now you can go through all of these yourself, but each of the other core part of the 6 trigonometric functions derivatives are listed here.